Welcome to the video. This is a short and very informative video about a model building. So in this video, we are going to see how to validate a model. On what basis we can say a model is a good predictive model. So we build a model to predict the value. Based on the x variable, we will predict the y variable. So how we can say the particular model is a good predictive model? So in order to say that the particular model is a good predictive model, we need to fulfill certain condition. That's called as the model validation. So in this video, we are going to see condition to be satisfied to call a model as a good predictive model. So let's see one by one. So I have categorized this into three conditions. First one is R square of the model, then the p value, then the condition 2 I have the RMSE of the model, then in condition 3 we talk about the residual validation. So let's see one by one. So first, after building a model, we need to check for the R square of that model. So we will get that R square in the summary of the model. So the R square of the model should be above 62%. So what is that R square? So R square means coefficient of determination. Think of R square as a measure of how well your model explains the variation in the dependent variable. A high R squared says about 60% indicates that a significant portion of the variability in your data is captured by the model. However, it's important to note that R squared alone doesn't tell you the whole story, and it's always good to consider other metrics along with it. So first we will consider about the R square. After building a model, we first check for the R square. We check whether the R square is more than 62. So what is that R square means? R square explains how well our independent variable means our x variable will determine the y variable. If it is R square is more, that means the independent variable, that x variable is efficiently have the contribution to predict the y variable. So R square of the model should be greater than 62%. So this is the interpretation about the R square. So always check the R square is about 62%. Then after that we will check for the p value of the each variable. Like the p value tells us the significance of each variable in the model. A p value less than 5%, typically considered as the standard threshold, suggests that the variable is likely contributing significantly to the model. If you have the variable with a high p value, it might be worth reevaluating their inclusion in the model or exploring transformation. So the p value of each x variable. We will get it in the summary of the model. So p value of the each variable should be less than 5%. If it is more than 5%, we have to remove that x-axis x variable from the model, then again build the model. So until all the p value less than 5%, we need to rebuild the model. So this is about the p-value. So check for p-value, make sure always p-value of the all the variables should be within 5%. So after the second condition about the RMSE. So what is that RMSE? RMSE should be within 10% of the average of actual y, means dependent factor. So RMSE means the full form root mean of squared error. So we will find the error in the model. So error means the difference between the predicted value and the actual value. So the error means the difference between the actual y and the predicted y. So we will take the mean. We will first take the sum and mean of that, make the mean of that, and we will take the square root of that. So that's why it's called as root of mean squared error. So first we will take the square of the error, then we will take the mean of that. After that, to normalize, we will take the root of that. So that RMSE of the residual means error should be within the 10% of the average actual, means y. How to get that 10%? How we can check that whether it is 10% or not? We have to take the average of y, actual y, then we have to take the RMSE root mean square error, we have to divide the mean root mean square error by the average of the y actual. Then if we find that that is within the 10%, it's good. If it's more than 10%, like 20, 35, so that condition not met, we will consider that the condition 2 is not met in this model. Then the RMSE. So RMSE gives us the idea of how well our model is prediction aligned with the actual value. We want the RMSE to be within 10% of the maximum possible error, means the average of the actual y. Then which is the average of the actual y value? If your RMSE is too high, it indicates that your model's prediction are deviating significantly from the true value. Means if we have the error, means RMS means what? It's a error. It's we can call it as a average of error. So our goal is that our model should prediction will have the less error. So if it is have the more error, it always gives the more than 10% value. So that's how we validate the model. It should be within the 10% of the actual maximum possible error. So that is the condition 2. The RMSE should be within the 10% of the average actual y. Then the condition 3 is about the residual validation. So we need to, in order to call the model as a good model, we need to consider the residual validation. Residual means the same, whatever we called as error means the difference between the y actual and the predicted y. So we need to validate that in order to call the model as a good model. So there are 3 conditions to be fulfilled in order to, in regarding the residual. That is, the mean of the residual should be 0. After getting the residual of the model, we have to get the mean of the residual. If it is 0, that condition is met. One condition of the residual is met. After that, we need to check for the residual should be normally distributed. Means it should be normally distributed. When we do the KD plot or the histogram of the residual, it should show the bell curve or like structure. It should show the bell curve. Then we can call it as it is normally distributed. There should not be any skewness in the residual. Then the condition 3 is the variation between the predicted y and the residual should be constant. Means it tells that there should no relationship between the predicted y and the residual. It should show the constant relationship. There should not be any relationship. So if the predicted y has any relationship with the residual, means if it is showing the positive relationship, what will happen is if we the y is increasing, the residual is also increasing. That means that if the y of y increasing, the residual also increasing. Means if the value increases, the error will increase. This is not good for us for our model, because the residual means the difference between the predicted y and the actual y. So there should not be any relationship between the y, predicted y and the residual. Then only we can call it as a good model. So these are the 3 conditions of the residual. So this is about the basic, the validation, how we validate the model. First, after fitting the model, we first look for the R square, whether it is more than 62%, the condition met. Then we look for the p-value of the all the variables like x variable. If the p-value is greater than 5%, we will remove that and again fit the model, get the summary, again check the p-value. We have to remove the p-value more than 5% in an iterative manner. Means consider, means if the we have the 10 variables, x variables, the p-value, check for the p-value, which p-value is moved, we have to first delete that, then again fit the model, then check for the p-value, then among this which p-value is moved, remove that, again build the model. Like that we have to do that until all the p-value become less than 5%. Then condition 2, the RMSE should be within 10%. After p-value is sorted, we will get the residual. The residual, the RMSE, we will get the residual. We have to square that. Then after that, get the mean of that, get the square root of that. We will get the RMSE. Then check the RMSE is within the 10% of the Average actual y means take the average of the actual y, then RMSE divided by actual y, we will get the one percentage. That should be within 10%. Then after that, as a condition 3, it's about the residual validation. The mean of the residual should be 0. Condition 1, the residual should be normally distributed. It should have the bell-shaped curve. Then the validation with the variation between the predicted y and the residual should be constant. So these are the 3 conditions to be fulfilled in order to call a model as a good model. So thank you for watching. Stay tuned for the next video.